chemical energetics. Learning outcomes of chemical energetics would be state that an exothermic reaction transfers thermal energy to the surroundings, leading to an increase in the temperature of the surroundings. The other learning outcome is state that an endothermic reaction takes in thermal energy from the surrounding, leading to a decrease in the temperature of the surroundings. What are exothermic reactions? The definition says that the reaction in which heat is released or given out to the surrounding. Let me write. The reaction in which heat is given out or released to the surrounding. As a result, there's a rise or increase in temperature of the surrounding. The temperature of the surrounding increases. Now let's talk about the examples of exothermic reactions. Some examples of exothermic reactions are combustion reactions, like methane, burning of carbon, respiration reactions. I'm writing the reaction equations for your convenience. This is a combustion reaction of methane. Let me write the state symbols. Now this reaction equation need to be balanced. Burning of carbon, state symbols, and this equation needs to be balanced. The last equation is about respiration reaction. This is glucose, oxygen, products are carbon dioxide, H2O, and heat. Write the state symbols. Let me check whether this equation is balanced. No, it's not balanced. You have noticed one thing, that heat is written on product side of this reaction. This indicates that heat is released, not absorbed during the reaction. Released to the surrounding. What are endothermic reactions? The definition of endothermic reaction is opposite to that of exothermic reactions, which mean the reaction in which heat is absorbed or taken in from the surrounding. Let me write the reaction the reactions in which heat is taken in or absorbed from the surrounding. Due to this reason, there's a drop or decrease in temperature of the surrounding. The temperature of the surrounding decreases. Now let's see some examples of endothermic reaction. Reactions like decomposition of limestone, dissolving salts in water, photosynthesis reaction, decomposition reactions, photosynthesis, etc. For your convenience, I am writing these reaction equations. The decomposition of limestone, the products are calcium oxide and carbon dioxide. First of all, let me check. Let me write the state symbols for these equations. This equation is balanced. Now I have to write heat on the top of the arrow. The other equation is about photosynthesis, which is the reaction between water and carbon dioxide. Products are glucose and oxygen. First of all, let me write the state symbols. Let's see each equation is balanced or not. This is not balanced. And here, sunlight is the source of energy. The other reaction is dissolving salt like NaNO3 in water. Write the state symbols. This reaction also takes in it. You have noticed one thing, that here in this case, the reaction heat is absorbed from the surrounding. That's why it's shown on the top of the arrow. These are the heat, form of the heat. Sunlight is also form of the heat. It's shown on the arrow, which indicate that heat is absorbed in this reaction. Absorbed from the surrounding. The learning outcomes for this topic is state the transfer of thermal energy during a reaction. It's called the enthalpy change. Delta H of the reaction. Delta H is negative for exothermic reactions and positive for endothermic reactions. Define activation energy EA as a minimum energy that colliding particles must have to react. Here's a summary of the last lesson. Exothermic reactions are those reactions in which heat is released, given out to the surrounding. Endothermic reactions are those reactions in which heat is absorbed or taken in from the surrounding. What is enthalpy change? It is the amount of heat released or taken in by a reaction, or the amount of energy change between the reactants and products. Let me write. It is the amount of heat released taken in by a reaction or you can even write the amount of energy change, the amount of energy change between the reactants and products. And the products. We can also call it heat of reaction. Heat of reaction. H is used to represent heat of reaction. H is heat of reaction. Therefore, in order to represent change in heat of reaction or enthalpy change, we use the symbol delta H. Delta H is enthalpy change. Or change in heat of reaction. Delta H for exothermic reactions. For all exothermic reactions, delta H will be negative, which indicates that heat is released to the surrounding. Heat is released to the surrounding. While delta H for endothermic reactions is always positive, which indicates that heat is absorbed from the surrounding. Heat is gained from the surrounding. Let's talk about energy barriers. What are energy barriers? For any reaction to start, every reactant particle or molecule has to pass through energy barrier before reacting. Let me write every reacting particle or molecule has to pass through energy barrier. Before reacting. What is activation energy? Activation energy is the minimum amount of energy needed to activate the reactant particles before any reaction to occur. It is the minimum amount of energy needed to activate the reactant particles before any reaction to occur. It is represented by EA. EA, activation energy. EA is always positive, whether it's exothermic reaction or endothermic reaction. For both exothermic and endothermic reactions. Today's lesson: draw, label, and interpret reaction pathway diagrams for exothermic and endothermic reactions using information provided to include reactants, products, enthalpy change of the reaction, delta H, activation energy, EA. Let's talk about reaction pathway diagrams. It's also known as energy profile diagrams. Also known as energy profile diagrams. It shows reactants, products involved in the reaction, as well as enthalpy change of the reaction, delta H, and activation energy, EA. Let's draw the energy profile diagram for exothermic reactions. This is x-axis. This is x-axis. This one is x-axis. And on x-axis, you are having time or progress of reaction. Progress of reaction. It's also known as a reaction coordinate. On y-axis, this is y-axis. This is energy or temperature. Now I will draw the line for reactants and products. This is the energy profile diagram or reaction pathway diagram for exothermic reaction. This is the line for reactants. Then we have to draw the hump. This is hump and this is the product. Let me write reactants, products. You have noticed one thing, that products is at the lower energy state than the reactant. The reason is that energy is released to the surrounding. Remember this, for any exothermic reaction, products will be at lower energy state. This is lower energy state. This is high energy state. Let me write here, high energy state. Now I'm going to show the enthalpy change of this reaction and activation energy. This will be the EA or activation energy, which is positive. Enthalpy change will be between reactant and product. So this will be the enthalpy change, and we use delta H. This is exothermic reaction, so I will write negative. So this is the energy profile diagram or reaction pathway diagram for any exothermic reaction. Now I want you to try reaction pathway diagram for an endothermic reaction. The hint here is product will be at high energy state than the reactants. First of all, you will draw x-axis and y-axis. On y-axis, you have energy or temperature. The unit will be centigrade. And on the x-axis, you have time or a reaction coordinate. As I told you, it's also known as reaction coordinate. Now I told you that product will be at high energy state than reactant. So this will be the reactant and this will be the product. So energy hump would be like this. This is the reactant and on this side you have products. Products is high energy state. The reason is that the heat is absorbed in this reaction. Low energy state. Let me write. This will be the EA or activation energy, which is always positive. And this is the delta H. And we know this is endothermic reaction. So the sign will be positive. Remember, for all endothermic reactions, the delta H will be positive. A mixture of ethanoic acid, ethane, and oxygen is passed over a catalyst at centigrade to manufacture ethanol ethanoate. The reaction is exothermic. This information is important. In the reaction, they are asking us to draw a reaction pathway diagram. And in the diagram, you have to label the axis, the reactants, products, the enthalpy change of the reaction, that is delta H, and the activation energy, EA. Now let's start working. First of all, We'll draw the y-axis and x-axis. This will be the y-axis and x-axis. Well, you know that we have to write time or reaction coordinate on x-axis, and on y-axis you have energy or temperature. I'm writing energy here. The unit will be centigrade. Now for any exothermic reaction, remember the reactants will be at high energy state than product. So this will be the reactant. This is the energy hump, the product. So you write the reactants here. And products. Now show enthalpy change and activation energy for this reaction. Activation energy for this reaction will be this one. Sign of EA will be positive, as I told you that for exothermic and endothermic reaction, it's always positive. This reaction is exothermic, so the delta H will be negative. The heat is released to the surrounding. Now let's see the learning outcomes of today's lesson. State that bond breaking is an endothermic process and bond making is an exothermic process, and explain the enthalpy change of a reaction in terms of bond breaking and bond making. Bond breaking involves or needs energy. So I will write here, it needs energy. In this case, delta H will be positive. In case of bond making, the energy is released. Energy is released. So delta H will be negative here. Now explain the enthalpy change of a reaction in terms of bond breaking and bond making. Enthalpy change in terms of bond breaking and bond making. Now I'm writing the statement for an endothermic reaction. Statement for an endothermic reaction. This is a situation when you have overall reaction is endothermic. How you write these statements? You write in this way: bond breaking is an endothermic, and bond making is exothermic. Less energy released than absorbed. Less energy released than absorbed. Ethanoic acid, ethane, and oxygen is passed over a catalyst at centigrade to manufacture ethynyl ethanoate. The reaction is exothermic. This information is important. It's exothermic. Explain with the enthalpy change of the reaction. Of this reaction is exothermic. Use ideas about bond breaking and bond making. Now I'm solving the question for you. The whole answer will be like this: bond breaking absorbs energy. Bond breaking absorbs energy, and bond making releases energy, and bond making releases energy. More energy released than absorbed. More energy released than absorbed. This will be the full answer. Now let's see the learning outcomes for today's lesson. Calculate enthalpy change of reaction using bond energies. In this lesson, I will talk about two things. First of all, I will start with the definition of bond energy. Then I will teach you how you are going to calculate the bond energy. Enthalpy change for reaction using bond energies data from a table which will be provided to you in the exam. Let's start with the definition of the bond energy. It's energy required in breaking the bond between two atoms. Energy required to break the bond between two atoms. It's the same amount of energy released when bond is made between these two atoms. It is the same amount of energy released when bond is made between these two atoms. Between these two atoms. It's measured in kilojoule per mole. Measured in kilojoule per mole. Bond energy measures the strength of a covalent bond. Bond energy measures the strength of a covalent bond. And hence the stability of the compound form and stability of the compound formed. Stronger bond needs higher amount of energy or vice versa. Stronger bond needs higher amount of energy or vice versa. Hence, exothermic reaction produces most stable compounds. Hence, exothermic reaction produces most stable compounds. Now let's talk about the enthalpy change of a reaction. How you are going to do the calculation? This is a question: calculate overall energy change for the reaction. We have been provided with this table of bond energies. This is a reaction between hydrogen molecule and chlorine molecule to produce two molecules of hydrogen chloride. First of all, what we have to do, we have to draw the display formula for these. For instance, we will have HH plus ClCl, and as there are two molecules of hydrogen chloride, so I will draw in this way: HCl, HCl. Now what I'm going to do, I will add up the bond energies of hydrogen and chlorine molecules. Both of these are reactant side. So what we will get? 436 plus 242. And the bond energy on the product side will be subtracted from these values. So we'll multiply 2 by 431. ClH means same as HCl. So what we will get? We will get this. $678 minus 861. The answer will be minus 183 kilojoule per mole. You see the sign? The sign tells us that this is an exothermic reaction. This is how you are going to calculate the enthalpy change for a reaction.